go through some post-optimality analysis. So I'm just going to go over one of the examples we started a linear programming discussion with and go over the sensitivity, and then we'll look at a new example, and hopefully with all of that we could get some general basic understanding. If you recall, and I will try to do one more, once you use the solver, after you solve, there is a pop-up that is actually asking you if you are interested in any sensitivity information. And I gave you guys a copy of it in Excel, and I kind of summarized it in here also, that we could look at a clean format, and then we look at the Excel information. Once you go through Excel sensitivity, it gives you all the information that we're going over with right now. This first example, let's take a look at this one last time. We have a linear programming type of a problem with a couple of products and 3 constraints. If you don't remember, based on our discussion last week, we went through a bunch of different formulations, and I'm hoping you guys kind of relate now to the basic formulation information. This particular problem was we had a couple of products, and we call those again X1, X2, and we have 3 production departments that we have labor hour available in these 3 production departments. These are departments 1, 2, and 3. So the 200 is just the labor hour we have available in our first department, 150 in our second department, and a 500 in a third department. The 15 and the 6 in the objective function coefficients are your profit contributions. And when you get your optimal solution, variable X1 and X2, you can just see that we work this problem graphically as well as looking at the Excel solution. And your value for X1 is 600 and for X2 is 0. That is just an indication that you are basically putting all your effort into manufacturing the maximum amount number of your first product, nothing of your second. And again, the reasoning for that, as we looked at our graphical solution, is the objective function coefficients, that they are determining which corner point or which will be an optimal solution. So when we looked at the graph for this particular problem and identified our say 2 constraints, our objective function line, and again one of these corner points will become an optimal solution to your particular problem. Your Excel starts at 0, 0, and it kind of moves. The slope of this objective function coefficient, which is again 15x1 plus 6x2, these 2 coefficients will determine the slope of the objective function line, and those are nothing but profit contribution. If you're making a lot of profit for one of your items, it just means that you want to focus or put all your efforts into making this particular product and not doing the second product. So this being X1 and that being X2, so we have a kind of a steep type of a slope for our objective function, which as you take this thing and move away from the origin, the last corner point will be this corner point, which would determine your optimal solution to your particular problem. And now we know the reasoning that we get the solution that we are getting in this particular problem. The reduced cost information. Now this is just something that we kind of talked about it. Now we're going through a detailed type post-optimality analysis. There's nothing you guys have to do manually. All of this will be part of your Excel output, and we'll look at the Excel information in just a sec. Reduced cost is just the additional profit a particular product needs to generate for that item to be included in your optimal solution. So currently our second product, if you recall, we said that we made the subset, X1 being a smart phone and X2 being some kind of a regular cell phone, and your regular cell phone not generating that much profit, so that's why you're just making as many units of your smartphone as you have resources for. And so currently this X2 has the objective function coefficient of $6, which basically we give it a C2 notation. So this profit needs to go up by at least $4.02. Then your your X2 will have a positive coefficient, positive value in your optimal solution. So for X2 to assume a positive value in the optimal solution, C2 needs to be increased by at least $4.02. So for this particular item, for X2, to assume a value, positive value in the optimal solution, C2, which is the objective function coefficient, needs to be increased by at least $4. And this is what we call a reduced cost. So reduced cost is just telling you some investments at the end of the when you put together your portfolio, some investments are not part of your portfolio because they're not generating that much return. So that particular stock needs to generate by the reduced cost that much more return to be included in the portfolio. So if all of your stocks are part of your portfolio, everything on the reduced cost is zero. So you can just see that when you have a value of 600 for X1, the reduced cost is zero. When the value for X2 is zero, then there is a positive reduced cost. So when you're actually going through your next case, you need to take advantage of this reduced cost information. And as far as exam questions, if you guys are concerned, is I might give you a same type of a handout, say if a unit profit for this particular product or for this investment, it goes up by another $1, would that be this particular now investment will be part of the portfolio? If it's less than reduced cost, no, it will not. But if it's at least minimum by reduced cost, then yes, you definitely. You win your information when this unit profit it goes up by reduced cost, then you need to resolve the problem. This is only telling you that you actually your optimal solution stays optimal as long as the unit profit for this is less than $4.02. When it goes up to $4.02 or more, then you need to resolve the problem and get a new solution. So that's the meaning of a reduced cost in your Excel, and that's just a part of the what we call post-optimality analysis. Are we good? We already talked about these briefly, but now we're getting to, now you guys have good understanding of the solution, the formulation, and what are the coefficients are all about. Now you can actually go through a proper interpretation of your sensitivity that is provided to you by your Excel or any other software that you work with. Any question on the reduced cost and as far as your complete understanding of this? And keep in mind, a lot of these you don't memorize, but you definitely want to have them on your cheat sheet somewhere that you know what the reduced cost does, that you could take advantage of your information and answer some questions. I'll let you know where this 4.02 comes from in just a sec. So be patient on that. But just for our purpose, your objective function is this guy here. And when you keeping, say, if I change this to 15x1 plus 9x2, it may generate additional $3 of profit. There's no reason to resolve the problem. You're still going to come up with x1 of 600 and x2 of 0. The only time that you need to resolve it when this guy goes up by at least $4.02. Then when you this changes to say 15x1 plus 10.02 times x1, then both x1 and x2 will take on positive values. So that's just the hopefully a good interpretation of these reduced cost information. Then your constraints, and we already talked about it. You guys did this, most of you, for your analysis. You have 3 constraints. Your right-hand side values are your limited resources. You have budget constraint, you have material constraints, you have a lot of limited resources. So 200, 150, and 500. So these original right-hand side values are 200, 150, and 500. Now, question is, how much of these are we using and what's the leftover? The leftover are what we call slacks. So after you go through production, some of your resources you completely use, and some of them you have some leftover. Those are what we call slacks. So slacks are unused resource. So unused resource, some leftover, something that you do not have, they have a slack of 0, and if you end up with a positive slack, that means that you have some unused resource, some extra material. So in this case here, you can just see that we have 50, 0, and 200. So what this piece of information, where is it coming from? Your Excel, just make a substitution of your optimal solution to each constraint and make a comparison with the original right-hand side, and all the difference will be your slack. So one last time, just kind of showing you guys one of these in your first constraint. Your optimal solution for this particular problem is x1 of 600 and x2 of 0. Your first constraint, which is 0.25 x1 plus 0.5 times x2, is less than or equal 200. If you plug in, and that's what the Excel does, is 0.25 times 600 plus 0.5 times 0, giving us 150. So this difference, which is 50, becomes an unused resource. So you're starting with 200. Anything that is available to you, we'll call it slacks. Most of the time, the terminology for your grade and equality constraints are called surpluses. They really don't have that much economic meaning. So there's just a lot of information that is on the Excel output. Not all of it is really useful for interpretation.
So my question is on the homework, you had minimum and maximum constraints. When you develop a slack for that, you just use the maximum?
Exactly. The minimum doesn't, yeah, exactly. That's a good question. The maximums are the ones that you're limited with. When you have a greater than, when you have a minimum, then that is called surplus, and it really is not really that much. Some people might have some use for it for some other purposes. For our, and that's just basically for type of applications that it gets involved with some chemical reactions or some scientific type experimentation. For business type application, we just looking at our slacks. These are always associated with less than or equality constraint. So slack always would be for your less than or equality constraints. And those are, if you have an equality, then you're forcing it to be equal to, you need to be on that line, and so there's really nothing going to be available. Your Excel will give you an information on an equality constraint, but it's not going to be really subject to any kind of an interpretation. The only thing that is of interest is just, so you always want to go back to your original constraints and look at your less than or equality constraints and your slack information associated with the less than or equality. We have in case, in this particular example, 3 less than or equality constraints, so there are 3 slacks. If I would have had only the first constraint to be a less than or equality, second one be greater than, and last one be an inequality, you're going to get some piece of information here which basically does not mean, does not have any kind of a economic meaning, so you can completely ignore it. So just only go over the less than or equality constraint and identify your slacks, and those will be for your, and I'll put it up here also, only for less than or equality constraints. So it's not really necessary for you to spend any time on the interpretation of greater than or equal to type constraint. After you identify your slacks, then we're going to have what we call dual prices, or sometimes called shadow prices. Dual prices or shadow prices are just the value, how much your profit will increase per additional unit of a limiting resource. So the increment in profit by 1 more unit of your limiting resources is what we call a dual price or shadow price. Okay, so that's your dual price or shadow price. These are increment in the total, say, profit by adding 1 additional unit of a limiting resource. So is your increment in your profit by actually adding one additional unit to this limiting. Limiting resources are the resources that they have zero slack. So the ones that they have absolutely none available, the only one that is actually a limiting resource is the second constraint. So you always have the dual prices. You can just see that for this is 0, for this is 0. There is no reason for you to get a number. You already have some excess. And getting any additional one will not really generate any additional profit. The only one that is actually giving you additional profit will be your second constraint. And that 60 will be a increment. So originally your second constraint which is 0.25x1 plus 0.167x2, 150. This particular constraint in this kind of a format with the right-hand side value of a 150, that is just the limiting resource. That's what you basically have. This will generate Z of $9,000. So that particular constraint generates that. What the Excel does, increases this to a 151. This stays the same, and your Z, it goes up to $9,060. So by adding one additional unit to the right hand side of the second resource, your profit will go up. This is actually sets a lot of businesses, a lot of manufacturers, they're actually looking at this particular piece of information, your dual prices, to identify how much they're willing to pay. If you go hire one more guy and this guy say, I want $60 to work for 1 hour, then it doesn't make any sense. You're gonna break even. But if you hire someone for $10, then it makes sense. So even for the raw material, the raw material, they have some, when you're running out and you basically are limiting, as I'll go back to the this furniture manufacturing and putting these, say, tables and chairs together, and all of a sudden I'm out of some, say, half-inch screw, and I don't have it. And I need to go, and that's the limiting constraint. That's the one that the slack is 0. When manufactured, these are, say, custom made, and you want just a few hundred pieces, and the manufacturer just looking at it, originally your order was for a larger quantity, now you want a couple of hundred pieces, and it might not really make sense for the factories to make that kind of a small quantity. When they give you high unit price, as long as that unit price is less than your shadow price or dual prices, it makes sense. But if it's anything more than that, then it does not make sense. So you always go with your unit prices and compare that with your shadow prices. So shadow prices or the dual prices is how much your profit will increase if you would have had one more unit of a right-hand side value. when you actually go through, if I would have had 2 units, 2 additional units, my profit will go up by 120. Okay? Why not just go ahead and buy gazillion amount of this and change it to say 1,500? We can answer that question. Why not? For each unit that goes up by $60, why not just keep adding?
At some point that will stop.
At some point, the other constraints will come into play, and you're gonna, one other constraint will be a limiting factor. So you cannot just buy, you need to basically buy for, as and most of the time, we kind of, when we just want to know the bottlenecks, where the bottleneck is, sometimes you're putting a limitation on one of your constraints, and that really has a significant impact on your return on your investment because of one restriction that you're imposing on your particular problem. And when you lift that restriction, then obviously you're going to have more room to make more returns, and these are the stuff that we get out of the post-optimality analysis. Any question as far as the interpretation of our slacks and dual prices or shadow prices? Are we good? Okay. I'm not really done. Your text is kind of an academic type of a text been written, and they go really by far more in detail, but I'm just kind of exposing you guys to the bottom line. I don't want to really go over and do a lot of unnecessary type calculations and get you to a point that we are right here.
So that brings up a good point, because problem 15 on the homework is very complex, very complicated. Would it, I mean, understanding that when you were showing us this, it's a more simple version of it.
Right.
Are we going to be tested at that complexity level?
No, you will not. That's a very good no question, guys, and I'm glad you asked the question. Some of you guys emailed me, and I responded, with the exception, you sent me an email, but I was waiting for your formulation and never got it. So I wasn't able to respond to you accurately. But when I'm giving you guys, if you recall, I told you guys last week, when you are working on your case, I didn't talk about the homework, I should have said that too. If you really get to a point that you're frustrated, let me know. Okay? Let me know, and I will get you guys started, and I will help. Didn't I say that about the case? And I said they can delay it 1 more week, and you guys kind of get it accurately. This is formulation or any other type topic that we cover. When you take things home and you have a bunch of you guys working together, you have plenty of time, and I'm also available. Some of you guys call me, some of you guys email me, and she texts. Which is fine. No, which is fine. So I have no problem, texting, emailing, calling. Sometimes we can talk about things and makes it easier. Sometimes we talk about, so when you take things home, just be comfortable contacting me. Don't get frustrated with anything we cover in this class. As a matter of fact, I was waiting for you guys to kind of contact me on your final project that you haven't done that yet. So I'm hoping at one point you guys have it in a type of a format that I can take a look at it and give you guys feedback, or if you have some type of a situation that needs some clarification. So don't get frustrated with anything. Once you take the information home, and because you're all professional, and I know you have your life, other classes, and work to need to be work done and you have limited time, I don't want this class to be kind of a factor that takes away from other things that you need to do. But so please contact me. I don't want you guys to get frustrated at all. So answer to your question is no. On exam, when you take your final exam, you're going to have number 14 type.
Oh.
Okay? Something very straightforward and to the point that you still need to formulate, but not with the complexity at all. Alrighty. Now, so we talked about the reduced cost, we talked about the slacks, and we talked about the dual prices. Are we good so far? Okay. Let's move to the objective function ranges. Now, this 15 that we have in a middle